Hello everyone, welcome to 30 Days Data Science Project Challenge Series playlist. Today we are going to discuss our project number 6, and in this particular video we are going to discuss end-to-end machine learning projects related to a banking domain. So let's first of all try to understand our problem statement, and based upon the problem statement we can load our data, we can perform a ADA exploratory data analysis, we can perform a data pre-processing, a complete feature engineering steps, and based upon that we can build our entire model. Again, that we are going to use a multiple machine learning model, and after that we can select a final model, we can do the feature selection, and based upon that we can build our entire project. Okay, so let's first of all try to understand our problem statement, because whenever we are working on any types of the data science project, first that we need to understand the problem statement. To perform the EDA we need to understand first of all our problem statement. So now let's try to understand our problem statement. So the problem statement we have, the data set is based of the direct marketing campaigns of the banking institution. These marketing campaigns were based on the phone calls, and more than one contact to a client was required in order to know if the product bank term deposit was subscribed by a client or not. So this is a classification problem statement that we have, and the main goal that we have to predict if a client will subscribe to a bank term deposit or not. So this is the main problem statement that we have, where we are going to classify whatever the client that we have in our banks, they can subscribe our bank term deposit or not. Okay, now in our data set that we have a 21 columns including our target columns. So what we are going to do, so we are going to discard our target columns and we can use a remaining column so that we can perform our complete ADA, we can perform our complete feature engineering. Based upon that we can predict, okay, whatever the customer that we have, they will subscribe our bank deposit or not. Okay, so this is the main problem statement we have. Now approach wise, so we are going to start with the data exploration, feature engineering, building a training model, validation and testing, model selection, after that a model evaluation. So this is a complete approach we are going to follow for this particular projects. Okay, now project definition wise, the classification goal is to predict if a client will subscribe to a bank term deposit or not. Okay, so I hope you will get an idea what is our problem statement. Now what we are going to do, so now we are going to import our all the important library. After that we can load our data, and then we can perform the EDA, we can do the complete data exploration, a feature engineering, we can build the model, we can select the model, and then we can do the evaluation. So in a same file I have a data set. So as you can see, bank additional hyphen full.csv. So we are going to use this particular data set to build an entire model. So let's first of all try to import our all the important library. So here we are going to import our all the important library called pandas, numpy, matplotlib, c1, and as well as here that I am going to set pd.set underscore option display.max column, because sometime what happen, let's say we have lots of column, 30-40 columns. So in between, whenever we are going to print a dot head or the dot tail, a top 5 of our data set, in this case that we are getting some of the hidden data. So that's why we are going to define here a display dot max columns. Now let me run this particular shell. Now we are able to import our all the important library. Now what we are going to do, so now we are going to read our data. So let me define here, so pd equal to df equal to pd dot read underscore csv. Then we are going to define our complete data, and separation we are going to define this one. Okay, now let's read a top 5 data. So df dot head, so we are going to read our top 5 data set. So let me run this particular cell. Now as you can see, this is the complete data that we have, and in this particular data that we have the multiple features as I have mentioned here. So we have total 21 features including our target column. So jobs, age, marital status, education, default, housing, loan, contact, month, days of the week, duration, campaign, place, and so on, all the information that we have related to our client. So these are the complete client information that we have, and the last column that we have our target column. Okay, subscribed, yes or no. Now what we are going to do, so now we are going to check the complete information for our data set. So df dot info function that we can call, and with the help of the info function that we will get the complete information related to our data set, where we will get our complete columns name, a data type, as well as a not null. So let me run this particular cell. Now you can see these are the complete information that we have. So here we have age, and this is the total rows that we have in our data set. So 41,188. So this is the enough data that we have. 41,000 is the enough data that we have. Based upon this particular data, we can perform our complete EDA data exploration, and then we can build our complete module after doing the feature engineering. Now along with this one, our column name, we have our data type. Okay, so age is a integer data type, job is a object, it means string data type, Martial again is a string data type, and so on. We have our complete information related to our all the features. Okay, now what we are going to do, so here we are going to check, okay, so in our data set that we have a null value or not. So for this one, that we are going to call a df dot is null, and after that we are going to call dot sum function. So let me execute first of all this one. So whenever we are going to execute this one, so as you can see here we have a true or false. So we are getting a false mainly. False, it means we did not have the null value here. True, it means we have the null value, but because as you can see here we have total 41,188 rows and 21 features that we have. So it's a very difficult to find out again in between the data that we have some of the hidden data. So it's a very difficult to find out, okay, so in which column and in which rows we have our missing value. So for this one, that we are calling dot sum function, and based upon this particular dot sum function, that we are getting the complete calculation, or we can say the sum of our all the null values. So let me execute. Now as you can see in our all the features we have our 0 null value. In our every features we have our 0 null value. Now what we are going to do, now we are going to count the number of rows for our target column. For our in our target column, that we have the two possibility, yes or no. No, right? A subscribed our term deposit, yes or no. So what we are going to do, so we are going to call the group by operation. So df dot group by, and in this particular group by, that we are going to define our target column name, our target column features name. So the target column name, that we have the y, so let me define y here, and after that we are going to call dot size function. So let me define the size. Now let me run. Now you can see here a no possibility that we have a 36,548 clients that did not subscribe our term deposit. Now if I talk about the subscribed part, so we have only 4,640 people and they have subscribed our term deposit. Okay, now what we are going to do, so here as you can see in our target column, that we have a two possibility called no and yes. So now we are going to do the encoding for this particular yes and no. So let me define here. So here we are going to create one of the features called output label, df output label. So this is the feature we are going to create, or we can say this is the column that we are going to create. And here we have a complete equation called df dot y equal to yes dot age type into the integer. So we are going to convert whatever the data type that we have right now, we are going to convert into the integer. So if I show you the current data type, so current data type that we have the object. Now we are going to convert this particular data type into the integer, where 0 we are going to represent a negative class, 0 we are going to represent the negative class, and 1 we are going to represent our positive class, that we can say yes. Okay, so now let me run this particular cell, and after that what I'm going to do, so I'm going to check our complete data frame. So df dot head, let me run. Let's check our last column. Now you can see here that we are getting our output level features, and these are all the no value that we have, no. Now what I can do, let me check the tail. So let me copy, let me paste here, and here I'm going to call a tail here. Let me run. Now you can see if I show you the last features again, so here we have a yes. So yes, it means 1 that we have, no, it means 0. So here we are able to convert our complete target column into the 0 and 1, where 0 represents no bank deposit, our client they are not going to subscribe our bank deposit, and 1 represent yes. So yes, our clients they are going to subscribe our bank deposit or bank term deposit. Okay, so now we are able to encode our complete target column. So what I'm going to do, so here I'm going to add one of the comment as well. So let me add, so that parallelly that you will get the idea. So let me run this particular cell. Now as you can see, I created a column called output label, which is going to represent 0 for the negative class and 1 for the positive class based upon the our data set. Okay, now what we are going to do, so now we are going to create a function. Why we are going to create function? So that we can calculate the percentage of our positive class called 1. So positive class, it means yes, for the yes that we are going to calculate the percentage. So what I'm going to do, first of all I'm going to define the function here. So yes, this is the function that we are going to create, and after that we are going to add a return statement. So let me add the return statement here. So yes, this is the return statement that we have, where we are going to call our actual y actual divided by length of y actual, and here that we are going to call the sum. So let me run this particular shell. Now we are able to create a complete function. Now let me add a print statement here. So yes, this is the print statement that we have, the prevalence of the positive class, and let me run. So we have a prevalence of the positive class is 0.113. It means the prevalence of the positive class that we have 11.3, which means our portion, or we can say the people who agree to take the term deposit called the positive class compared to the our who did not select it our negative class. So here we have 11 point that we can write in this way. So yes, 11.3% people they are agree to take our bank term deposit. They are successfully able to subscribe our bank term deposit loan. Okay, so only 11.3% of the people. So look like again that we have some of the imbalance data. Even if I show you here, so as you can see we have our imbalance data here. So again going forward that we need to handle this particular imbalance data. As for this particular group by that we are able to check. Okay, so in our data set, in our target column that we have some of the imbalance data. So going forward that we can handle. Even here we are able to check. Okay, so the positive class that we have only 11.3% of peoples they are agree to take our, and they have successfully take our complete loan. Okay, so now let's proceed next. So next what we are going to do, so next that we are going to check our unique data for our data set. So for this one what we are going to do, so again that we are going to call a list operation. So df list of the column and df dot column. So what we are going to do, so here we are going to select our first top 10 features that we are going to select. As we all know, in our data set that we have total 21. Again we have created one more features called total 22 features that we have. So what we are going to do, so we are going to select top 10 features from the starting. So age, 1, job, marital status, education, default, housing loan, contact, month and the day of week. So these are the complete top 10 features that we have. First we can say not a top, first 10 features that we have. So we are going to select here a top first 10 features. Let me run this particular cell. Now you can see all the first 10 features that we have. Now same that we are going to select, let's say that we want to check our last 10 features. In this case that we can change this particular data only. Okay, so here that we are calling all the rows for our first 10 features. Now we can call all the rows from our last 10 features. So let me run. Now you can see duration, campaign, P day, previous, P outcome, empire rate and the so on column name, as well as we have a target column and the output label column. So now we are able to access a last 10 features, and here that we have our first 10 features. Okay, now what we are going to do, so now let me check our information of our data again. So because I need to check the complete data once. Okay, so now I need to call this one. Okay, so here we have output label called integer type that we have. Now total how many column that we have, so let's print the length of our column. So here we are going to print the length of the column, so number of the column and length df dot column that we are going to call. So now as you can see here we have a total 22 column that we have, because we have created one column called our output label, a new column that we have created. Now what we are going to do, so in our data set as you can see here we have our multiple data set, multiple features that we have. Let's say a job, a marital status, a education, again the housing, again a contact, a month, a day of the week, a p outcome, so many other features that we have. So what we are going to do for our all the features, for our all the categorical features, that we are going to find out the unique data. Okay, so in our job, how many unique data that we have? In our commercial, how many unique data that we have? Again in a education, again in a default, a housing, and the so on, for our all the categorical features. So what I'm going to do here, I'm going to write a for loop. So let me write a complete for loop. So yes, for a in list of the columns, so here we are going to call our all the column, list of the column, and after that we are going to iterate one by one. Now get a list of the unique value. So here we are going to find out the unique value from our all the columns, whatever the column that we are going to iterate here. Okay, so here as you can see, df a, it means every iteration that we are going to find out the unique value from our features. Now if the number of unique value is less than 30, print the values, otherwise print the number of the unique value. Okay, so here we are going to write the condition, if length less than 30, in this case print our column name less than 30, it means print the value, otherwise print the unique value. Okay, so here we are going to print the our all the important all the features, and here we are going to print the number of the unique value, else that we will get our complete unique value. So let me run this particular shell. Now as you can see here that we are getting our complete output. So for the age total that we have a 78 unique value. So based upon this particular condition, here the condition that we have, if the number of the unique value is less than 30, in this case that we can print all the value, else we can print the number of the unique value. So total unique value that we have a 78 value that we have. Now in a job we have a sum of the unique value like housemaid, a service, admin, a blue collar, technician, retired, management, unemployed, self-employed, unknown, entrepreneur, and the student. So on we have the martial, so again married, single, divorced, unknown. Okay, now we have education, different education degree that we have for our client. Now default, no, unknown, yes, housing, no, yes, unknown, loan, no, yes, unknown, contact, telephone, and the seller. Month, so total 12 month that we have starting from the Jan to December. Day of the week, so okay, so day of the week that we have a 5. Okay, so 1 2 3 4 5 6 7 8 9 10, total 10 month that we have. Now day of the week, so 5 working days data that we have. Now duration, so 1544 unique value that we have in our duration. Campaign wise 42. P days, so these are the unique value that we have for our categorical as well as for our numerical. So here we are able to get our complete unique value for our all the features, whatever the features that we have in our data set. Again here that we have for our all the outcome, our target column. So we are able to find out all the unique value for our all the features, whatever the 22 features that we have. Okay, now what we are going to do next, as you can see, as for this particular observation. Okay, so from our output code we can see that that our roughly the sum of the categorical and the numerical values that we have in our data set. First thing, now in our age, in our duration, in our campaign, a p days, a previous. Okay, so these are some of the, as you can see, the age, first age that we have, second that we have the duration somewhere. Let me check it out, the duration. So yes, duration, again campaign, a p days, previous, okay, EMP var rate. So these are some of the numerical features that we have. Now if I talk about the target features, so yes, we have a target feature called no, yes, and here that we are able to convert our target features into the 0 and 1. 0 it means no, 1 it means yes. Okay, now one more thing that we have here, as you can see in our duration column, what we are going to do, this particular duration column. So yes, this is the duration column that we have, and in this particular duration column we have a total 1544. So what we are going to do, 44 unique value that we have. So what we are going to do, we are going to discard our duration column. Why? Because this is the highly affect column that we have, and this particular column it will affect over our target column, so that's why we are going to drop this particular complete features. Now I have a complete note here, so let me put it down, the complete note related to this particular data. So here that I'm going to select the new shell, and in this particular new shell that I'm going to add our comment here. So let me add, yes, so we are discarding our duration features. So this attribute highly affect the output target feature. Example, if the duration is 0, then y equal to no. Okay, target column is equal to no yet. So the duration is not no before a cell is performed. So also after the end of the cell y is obviously known. So this input should only be include the benchmark process and should be discard if the intention to have the realistic predicted model. So that's why we are going to discard or we are going to remove this particular features in our upcoming coding. Okay, so we can discard this particular duration features, because this particular features it is going to affect our target column, because definitely if the duration is 0, so let me run our head. So df dot head, and here that I'm going to call 10, and let me run once. So if I show you the duration, okay, so duration by that we have some of the features, but let's say somewhere that we have the 0, it means 0, it means no, so it will affect on our target column. So that's why we are going to drop our duration features from our data set. Now what we are going to do, now we are going to start a feature engineering. So let me select the markdown from here. Now we are going to start a complete feature engineering. So till here we are able to explore our data set, right? So what we are going to do, so now we are going to apply, or before applying the feature engineering, let's try to do the data visualization. Okay, so now let's start a data visualization. So here what we are going to do, so first of all that we are going to select our numerical column. So let me select our numerical column. So here we are going to create one of the variable called columns numerical, and here we are going to mention our all the numerical column. Let me run this particular shell. Now let me check the top 10 value or top 5 value head. Now let me run. So okay, so head, okay, so here what we can do, so in this case that we can define from our data, so df, and from our df that we are going to define our columns, and from the columns then we can call our head. Let me run. Now you can see these are the our all the numerical features that we have from our data set. Now what we are going to do, now we are going to do the visualization. So what we are going to do, first that we are going to select our age column. So this is the age column that we have. So we are going to check, okay, so whatever the client that we have, so most of our client, they are belonging to which category, like the age from the like 20 to 30 or 25 to 30 or 30 to 35 or the 35 to 40 and the so on. So we are going to check, or we are going to do the visualization for our age column, so that we will get the idea. Okay, so we have a 20 to 25 age group people. Most of the people, they are belonging to 20 to 25 or 25 to 30 or 35 to 40 and the so on. Okay, so let's do the visualization. So first of all what we are going to do, so we are going to import our all the important libraries. Let me import here. Now we are going to do the plotting. So let me plot our complete graph here. So let me add here, and now we are going to plot a subplot. Okay, now here we are going to define a count plot. So sns.count plot, where we have a x age and the data that we are going to call our all the numerical features. We are going to set the x label, y label, title, and now we are going to run. So let me run this particular shell. Let's wait a few seconds. So now as you can see, a total client's information, a total client age information that we have. Now starting from the 17 and ending that we have a 98. Okay, so this is the huge amounts of the features that we have, huge amounts of the customer or our client that we have this part based upon this particular group. Now if I talk about the most occurring age group, so the most occurring age group that we have is starting from the 29 until that we can say a 37. So 29 to 37, most of the our client or most of our customers, they are belonging to 29 to 37 age group. So again, as a salesperson or as a marketing person from the banking side, that we can target a 29, or we can say yes, 29 to 37 age group person. Okay, now what we are going to do, so now we are going to do the visualization for our age as well as for our, let's try to plot a box plot as well as a distribution plot. So now let me plot here. So here what we are going to do, so we are going to plot the box plot. So sns.box plot, we are going to define age, we are going to call the columns, and the orient that we are going to define axis. Now these are the label that we are going to set. So x label, y label, title, and then parameter that we have. Now second, that we are going to plot a dash plot so that we will get the idea. Okay, so whatever the age group data that we have, but based upon this particular data that we are able to get. Okay, so first that we have most of our customers, they are belonging to 29 to 37 age group, but we have some of the right skew data. But let's try to plot with the box plot as well as a dash plot so that we will get the clear understanding. So let me run. Let's wait a few seconds. Now as you can see, this is the complete graph that we are getting. So as you can see in a box plot graph, some of the, as you can see here again, some of our customers, they are belonging to like above 88. So again same thing that we have here. So some people, they are belonging to 98, 97, 96. So we have some of the outliers in our age features, because yeah, definitely, like if the people, they have the age group, we can say the 90, 98 or like the 95 or the 90, then they can't take the term deposit loan, they can't subscribe our term deposit loan, right? So again, these are some of the outliers that we have. Again, if I talk about the dash plot, so this is the complete dash plot that we have, and as you can see, same whatever the understanding that we have, same understanding that we are getting here. Okay, so the people, the age group from starting from the 29 to 37, they are occurring more in our data set. Okay, now again this particular graph, as you can see, this is the little bit we can say the right skew graph that we have. Okay, so again the going forward that we need to convert this particular data into the normal distribution format, and if possible in this case, like again that we have the little bit about the outliers, but going forward that we can handle our outliers as well. Okay, now let me check it out our data here. So we are able to check for the age. Okay, now what I can do, let me check it out for the previous column. Okay, so now what is this particular previous column? So the previous is the number of the contacts. So let's say in our data we have a different types of the features. Okay, now let me add it down here. So what we are going to do, first let me write the code and then we can understand. So here we are going to write, we are going to do the complete plotting. So again count plot that we are going to plot. So x features that we are going to define the previous, a data, our data frame. Now set x label, y label, title, and then we are going to do the plotting here. So let me plot here. Now as you can see, this is the complete graph that we have, but let's try to understand what is this particular previous features. So the previous features that we have, the number of the contacts performed before this campaign and for this particular client. So let's say as a bank manager, as this is the November month, so as a bank manager in a first week of November that I have run the complete campaign to subscribe this particular loan, a term deposit loan. Okay, so now here we are going to check it out. Okay, so how many times before running a campaign, like in October or in August, our salesperson or our marketing person, they have connected to our clients. So now as you can see, a 0 time connected, that we have a total 35,000 people. 35,000 people, they our customers, our sales team as well as our marketing team, they did not have connected before the campaign run. It means these are the leads that we received after running a complete marketing campaign. So these are the 35,000 lead that we have, the original lead. Now we are getting the lead. So now our salesperson, we can send this particular complete data to our salesperson or the marketing person, and they can connect this particular person, and then they can convert this particular complete data into the our yes term deposit part. They can subscribe this particular our term deposit. So we can convert this particular complete lead data into the conversion. Now if I talk about the other part, so yes, some of the customer that we have, our sales team, they have connected 1 time, some customer they have connected 2 times, for some customer they have connected 3 times, and so on. Okay, but most of the new data that we have after running a marketing campaign, so yes, we have the huge chances our sales team or our marketing team, they can convert this particular lead into the final conversion where our customers, they can subscribe our term deposit loan. Okay, so this is the main meaning that we have for this particular previous feature. So number of the contacts performed before this campaign and for this client. Okay, now what we are going to do, so now we are going to select, let's select some other features. So now we are going to select from here our, let's say employee variation rate. So this is the employee variation rate. Let's try to plot a graph based upon our employee variation rate features. So let me select here. So again that we are going to do the plotting for our count plot. So sns.count plot, we are going to define our x features. Here we are going to call our data, so data df dot column all the numerical features, and now we have our x label, y label, titles, and our parameter. Let me run this particular shell. Let's wait. As you can see here, so let me write it down the complete description related to our emp.var.rate features. So we have the description called employment variation rate, so on the quarterly indicator. So as you can see, employer variation, the most of the variation that we have 1.4. How much? Approx we can say a 16,000 variation that we have. Now we have some of the negative as well. So if I talk about so this is all about our positive variation. Now if I talk about the negative variation, so we have minus 1.8, a highest variation that we have in a negative term, approx that we can say 90,000 or the 95,000 variation that we have. Right, now what we are going to do, so now let's try to check the missing value. We are able to understand little bit about our data for our age features, for our previous features, for our employee variation rate features. Now let's try to check the null value in our all the numerical features. So for this one that we are going to call df or columns variable is null dot sum. Let me run this particular cell. Again, as you can see, we did not have any types of the null value. Okay, so till now here we are able to visualize our complete data for our, we can say here, let me add it down the next comment here for our numerical features. Let me run for the numerical features. Now what we are going to do, now we are going to perform for our categorical features. So let me add a complete comment here. So categorical features, let me select the markdown from here, categorical features. Okay, so now again that I'm going to create a variable where we can define a complete categorical features into the list. So let me define here. So these are the complete categorical features that we have. Now let me run this particular shell. Again that I'm going to check the null value first of all in this particular complete categorical features. Let me define this particular variable. Let's change variable. Let me run. Now you can see again that we have the 0 null value in our all the categorical features. Okay, now as we all know, we have our categorical feature. These are the complete categorical feature that we have. So at the end what we need to do, so we need to perform a encoding. We need to convert our complete categorical data into the numerical format, because what happened, whatever the machine learning algorithm that we have, we need to provide or we need to pass a data, complete numerical data, so that we can fit into our model, into our machine learning model anyhow. So what we can do here, whatever the categorical features that we have like job, martial, education, default, housing, loan, and so on, whatever the features that we have, now we are going to convert our call the categorical features into the numerical format. So for this one what we are going to do, so we are going to use a one hot encoding technique. So in a one hot encoding technique what happened, so let's say here we have, if we talk about our, let's say the martial. So if I talk about the martial features, so in our martial features that we have a total 3 unique features that we have. Let's say unmarried, second that we have a married, and third we have, let's say, the no idea, and one more that we have the relationship. Okay, so these types of the data that we have. So what happened, whenever we are going to perform one hot encoding, so let's say if our unmarried matched, in this case that we will get unmarried for 1, and for our all the rest value that we will get 0. So 0 0 0 0. Okay, now let's say a second time that we are getting a row, in a row that we are getting a married. In this case that we can call first data that we have a 0 for the married, second for that we can call 1, and rest all the data that we can say a 0. Okay, so whenever our value it will get matched, that we can assign 1, rest all the values that we can call as a 0. So this is called a one hot encoding technique. So here what we are going to do, so we are going to apply one hot encoding technique. So let me mark down one hot encoding technique. So for this one what we are going to do, so we are going to create one of the variable called column new categorical, and we are going to call the pd.getDummies method, and with the help of pd.getDummies method that we are going to convert our categorical data into the numerical format. Now here we are going to call our variable called this particular variable. After that we are going to drop first. So drop first equal to false, it means we are not going to drop the first value. Now head, okay, so we are going to print the top 5 rows. So let me run. Now as you can see here, so we are able to convert here, as you can see, the false. So we have this particular categorical data. This is fine, okay, because at the end, as you can see, so if I show you the one thing here, so true, it means this is the one value that we have, and rest all the false that we have a 0. It means that we are matching a first time called job housemaid. Now if I talk about the next one, so if I show you this one, this particular complete data, so only one times true data that we will get based upon the one hot encoding technique. So let me show you. Just try to focus on the first rows. Okay, so let me show you. Let me scroll little bit right side. Okay, so now as you can see, these are the complete data that we are getting, and here as you can see, so if I show you for this one job, related to job only, so related to the job till here data that we have, till here. Okay, now as you can see, only one true value that we have. It means this is the only one value that we are able to get, rest all the value that we can say 0. Okay, now if I talk about the next features, so next features that we have here, what? Next feature that we have the Martial, so divorce, Martial married, a Martial single, unknown. So as you can see, again in this particular 4 values, only one time that we are getting a true, it means this particular is married, rest all the values that we are getting a false, it means these are the 0 value that we have. So now we are able to convert our complete categorical data into the numerical format. Okay, now what I'm going to do, so now we are going to do the representation, or now we are going to do the plotting for our categorical data. So here what I'm going to do, so first I'm going to select our education features. So let me select the education features and let's do the plotting. So let me run. This is the complete code that we have. So we have already our all the library. Now we are going to do the subplot, a size that we are going to set, so 25:8, count plot that we are going to plot a count plot, X education, and this is the column that we are going to define. Now X level, Y level, title, this, so these are the things that we are going to set. Let me run this particular cell now. Now as you can see, so whatever the client that we have, most of the clients, they did the bachelor degree, university, it means the bachelor degree, okay, and some of the clients, they did the literature degree. Okay, now a first highest degree that we have the bachelor degree, after that we have the high school. Okay, so this is the complete information that we are getting. Okay, so like whatever the client that we have, so they did the, like most of the client, they did the bachelor degree, after that the high school, then we can say the basics. So these are the complete degree that we have. Now next what we are going to do, so now that we are going to do the plotting for our Martial status. So let me do the plotting. So again that we are going to do the plotting for the count plot. Let me run this particular cell. Now as you can see, most of our clients, they are married. So as a salesperson, let's say if I'm a salesperson or the marketing person, in this case, first of all, that I will try to focus on the married person, because what happened in a married person, they easily take the loan for the house loan or any types of loan, whatever they think, okay, so this particular loan that I need, okay, a house loan, or let's say for the child, any types of the education loan, okay, or the car loan. Okay, so first, if I'm a salesperson or if I'm a marketing person, in this case, the first I will try to focus on the married, then I will try to focus on the divorce, then single, and then we have the unknown. So again, based upon our data, we have a married person more in our data set. Whenever we run the campaign, we got the more read related to the married person. Okay, now let's try to do the plotting based upon the job status. So again that we are going to select the job status features here. SNS dot account plot, we are going to select the features called job or data collection. Again that we are going to set all the level called X level, Y level, titles, and then we are going to set parameters. Now let me run this particular cell. Now as you can see, our all the job title that we have the housemaid, service, admin, blue collar, a technician, retired, management, unemployed, self-employed, unknown, entrepreneur, or the student. Okay, so most of the, we can say a less value that we have for the unknown and the student in our data set. Now most of the our customers, they are working as an admin, blue collar, as well as a technician. Okay, so most of the our client, or we can say our customers, they are working as an admin, developer, admin part, or the blue collar, or a technician. Some of the customers that we have the student or the unknown. Again, if I'm a salesperson or the management person, in this case the first that I will try to focus on this particular job person, like the serviceman, admin, blue collar, technician, management, then entrepreneur, and after that unemployed, self-employed, unknown, student, retired, and the house mode. Because if the people are working in any types of the companies, or they are the entrepreneur, or they are the management person, in this case that we have the high chances they can subscribe our loan. Okay, so first that we can focus on this particular part: admin, a blue collar, technician, a serviceman, a management, entrepreneur, and then we can focus on some other part called self-employed, or the unemployed, or the student, or the retired, or the housemaid. Okay, now what we are going to do? So now that we are going to do the plotting for our next feature. So let me check it out, the next features here. So the next features that we have here, let's plot the plotting for the P outcome. So what is the P outcome? So let me plot the first of all the graph here. So here we are going to do the plotting for our next features called P outcome. Now what is the P outcome? So in our P outcome, whatever the data that we have, so for this particular outcome, like for this particular data, how much outcome that we are getting, a success, or like existence, or the failure. So let's say total 10 data that we have, total 10 leads that we are getting. So from this particular 10 leads, how much lead that we are able to convert successfully? Okay, so I can say, let's say the 2 leads conversion. Okay, second point that we have, like, okay, so how many failure that we have? So let's say the 7 failure that we have. Okay, now apart from this one that we can say, let's say the 1, so 7 to 9, and 1 that we can say, okay, so these are the not existence, or we can say these are the incorrect information that we have, So total 3 types of the value that we have, unique value that we have in this particular P outcome features. First is a success, second is a failure, and third is a incorrect information, we can say the non-existence. So let me run this particular cell. So now as you can see, non-existence features that we have, most of the people that we have the non-existence features. Again, this is not an incorrect information, we can say the non-existence. Okay, now if I talk about the failure, so the failure that we have approx, we can say the 4,000, and success that we have out of 41,000, only 3 to 4,000 that we have the success conversion. So again, this is the huge amounts of the conversion that we have, because whenever as a marketing person, whenever we run any types of the lead, so out of 1,000 that we can convert only 1 or 2 leads. Okay, now here out of 41,000, our salesperson and the marketing person, they are successfully convert approx 2 to 3,000 of the lead. So again, this is the huge amounts of the success that we have. Okay, now what we are going to do? So now that we are going to do the plotting for some other value called, let me check it out here. So some other value called housing, loan, as well as for the default. So let me do the plotting for some other features. So here that we are going to do the plotting for some other features. So again, that we are going to plot account plot. Here that we are going to define the figure x1, x2, and the x3. Okay, now we are going to set the complete x label, y label, and the title. Again, here we have our housing column. So again, count plot, and here we have a loan. So again, in a loan that we have a total 3 column, no, unknown, yes. So order that we are going to set. Again, in a housing that we have a 3 features, and again in a order that we have a 3 features. Okay, so let me run this particular cell. Now as you can see, this is the complete value that we are getting. Now in this particular value, as you can see, the default that we have, the highest value that we have a default, and the lowest that value that we have the yes. Now if I talk about the housing loan, so we have approx, we can say 20, like I can say the 17,000 or the 18,000, and if I talk about the yes, so we have the highest value in yes. Now again in a loan, so we have approx 34,000, yes, unknown 0, unknown somewhere we can say the 1,000, and yes that we have approx 7,000. Okay, so these are the complete information that we are getting related to our default features, related to our housing features, and our loan features. Now one more plotting that we can do related to our next features. So next features that we have, let me add here. So next feature that we are going to select our contact, our month, as well as day of the week. So again here we are going to define our complete order for our month. So let me run. Let's wait a few seconds. Now as you can see, this is the complete contact that we have. So most of the time that we as a salesperson that we connect with the cell phone, and less time that we connect with the telephone. Okay, now month. So in a my month that we are generating a more lead in a May month and less lead that we are generating in a December, because mostly December is a closing month that we have. Now day week, so if I talk about the day week, so we have the month mostly Thursday and less that we have in a Tuesday and the Wednesday. So in this way that we are getting information, okay, so in which month that we are getting the more lead, in which week that we are getting the more lead, and in which way that we connect our customer, like the seller or the telephone. Okay, now what we are going to do, so now we are going to concatenate our complete data. So let's try to concatenate with our existing features. So now we are going to concatenate. So df pd dot concatenate our original data with our new column or whatever the new categorical column that we have created, and here we are going to pass axis equal to 1. So now let me run. Now what we are going to do next, so next that we are going to call our list of the column. So all the list and then column, let me call this one, and after that we are going to check the head of our all the categorical features. So let me run here. Now you can see here that we are getting our complete data. So this is the complete data that we are getting, a true or false, a complete data that we are able to access. Now in this particular data, total 5 rows that we have right now, because we have called the head, and total 53 features that we have, or the 53 columns that we have. Now what I can do, let's try to check the summary of our complete feature engineering. So here that we are going to check the complete feature like the complete summary. So total number of the features that we have are 62, numerical features that we have are 9, and the categorical features that we have a total 53. Okay, so total, if I talk about the total features, 62, numerical features 9, and the categorical features that we have are 62. Now what we are going to do, now that we are going to do do the complete like the sorting. So let's try to apply the complete sorting. So what we are going to do here, so here we are going to add our categorical and the numerical features. We are going to check the null value, and after that we are going to sort in a descending order. Ascending equal to false, it means a descending order that we are going to sort. So first that we are going to do the addition for our numerical as well as a categorical features. Then we are going to check the null value, and after that we are going to sort based upon the descending order. So let me run. Now as you can see, this is the complete data that we are getting. Okay, so now we did not have any types of the empty cell. Okay, so we have created a new data frame. So now what I can do, let's try to create a new data frame here. So we are going to create a new data frame called columns input, where we are going to do the concatenation for our, we are going to do the addition for our numerical as well as a categorical features, and here we are going to add our output level as well. So let me run this particular cell, and after that we can call our data column. So let me call our data column. Okay, so as you can see, total 63 features that we have, and if I show you here, so total 62, because we have added here a target column, that's why we are getting a 63 features. Now if I show you the column input, so let me show you the column input here. So yes, this is the complete column input that we have. So these are the complete column name that we have. Okay, so these are the complete column name that we are getting related to our data set. Now what I can do, let me check the length of our column input. So again, we all know, but let me check it out once. 62 columns name or columns input that we are getting. Okay, now let me plot the top 10 heads. So again, that I'm going to plot the top 10 or top 6. So let me run. So yes, these are the complete data that we are getting. Okay, so till here that we are able to do the visualization, we are able to perform some of the EDA. Now what we can do, so now that we can build a training model, we can do the validation, and after that we can test our model. Okay, building, training, validation, and test set. Let me add as a markdown here. Let me run this particular cell. Okay, now what we are going to do, whatever the original data set that we have, so from our original data set, 70% of the data we are going to use for the training purpose, 15% of the data we are going to use for the validation purpose, and 15% of the data that we are going to use for the testing purpose. So if I write in this way, so first what we are going to do, so first that we are going to divide our 100% data set into the 70 and 30. So 70 is to 30. 70% of the data that we are going to use for the training purpose, and 30% of the data we are going to use for the validation and testing purpose. Okay, now this particular 30% of the data later part that we can divide into the 15. So 15 for validation and 15 for testing. Okay, so in this way we are going to divide our complete original data set so that we can do the validation as well as we can do the sample test. Okay, so here that we can define a test samples. Okay, now what I'm going to do, let me define first of all, let me shuffle first of all our complete original data. So here we are going to do the shuffling. So data, df underscore data equal to df underscore data. So we are going to call our main data set dot sample, and here we are going to call the length of the data, random state, and after that we are going to call the reset index. So we are going to shuffle our original data set. Let me run this particular cell. Okay, now next what we are going to do, so now that we are going to divide our complete data, or we are going to take a 30% of the data from our original data, so that later part, this particular 30% of the data that we can divide for the validation and testing purpose. So let me define here. So here again that we are going to create a variable called df underscore valid underscore test equal to df data dot sample, and the fraction value that we are going to define 30%. Now this particular 30% of the data, later part that we can divide into the 15 and 15, a 15% data for the validation, 15% of the data for the testing sample. Now let me run this particular shell. Now you can see this is the complete splitted size that we have. So first of all that we have splitted our complete data into the 70 and 30. Now this particular 30% of the data, now we are going to divide into the validation and for the testing sample. Okay, so for this one what I'm going to do, again I'm going to create one variable. So let me create the variable. So yes, df underscore test, we are going to call our this particular validation test data set, and from here fraction we are going to define a 50. Why 50? 0.5, it means 50, it means whatever this particular 30% of the data that we have, so from this particular 30% of the data that we are going to use 15% data for the validation, and we are going to use a 15% of the data for the sample test. So what we are going to do here in a sample test, again this is the split size that we are going to take. So this is the original data that we have. Original, it means 100%. So from this particular 100% of the data, we are going to take a fraction 15%. So this particular 15% data we can use, 50% data we can use for the testing, and whatever the rest data that we have of 50% we can use for the validation. Let me run, then I will show you the output. So let me run this particular shell. Okay, now what we are going to do, so let me print the shape. So print df dot test, df underscore test dot shape, and this is our test size data that we have, a test sample that we have, 6171 rows and 63 columns. Now let's check for the validation. Okay, so here that we are going to check for the validation. Let me run this particular cell. Now as you can see here that we have 6178 rows and the 63 columns. Now we are able to split our original data into the 70 and 30 first, and now whatever the 30% of the data that we have, we are going to use this particular 30% of the data for the validation purpose, 15% validation and 15% testing. Okay, now what we are going to do, so now whatever the rest data that we have, we can use for the training purpose. So now we are going to drop from our original data. So here we are going to call df underscore train underscore all df data. So from our df data that we are going to drop our df valid test. So what is the df valid test? A 30% of the data. So originally that we will get the 70% data that whenever we are going to drop our 30% of the data. So let me run. Now if I run this particular shape, so print df underscore train all dot shape, and let me call here. So now as you can see 28,832 original data that we have. Our, if I add this one plus 6178 plus, and if I run this one, so as you can see 41,188 data that we have. And if I show you our original data set, so yes, this is our original data set that we have, 41,188, right? So same way what we are going to do here, so here that we are able to split our original data first of all into the training and testing. Now whatever the 30% of the data that we have for the testing purpose, this particular 30% of the data we are going to use for the validation as well as a testing. So 50% validation and 50% testing. From where? From this particular 30% of the data. Okay, I hope you got the idea. Now what we are going to do, so now let's start to print the complete shape or the percentage of the data. So here that we are going to call the check the prevalence of each data, test prevalence, validation as well as a train all. Now let me call these particular things. So here as you can see 6178 and the 28. So here we have our complete original data. So what we are going to do here we are going to call the length of our text, length of our validation and length of our all train data. We are going to call the calculate prevalence percentage, and here that we are going to call our output level. So df underscore test output level value, validation value and the train value. Okay, now what we are going to do, so as we all know in our data set that we have the imbalanced data. So if I show you again, so here as you can see somewhere that we have printed our target column. So if I show you, so as you can see this is our target column that we have printed, and based upon this particular value that we are able to get to know, okay, so in our data set that we have the imbalanced data. So now what we are going to do, so now we are going to handle this particular imbalanced data. So for this one what I'm going to do, so let me go below, and here that we are going to split the training data into the positive and into the negative. So let me define here. So yes, split the training data into the positive and the negative. So what we are going to do, so we are going to call here a rows underscore positive for the positive class, df underscore train all. So our training data that we are going to call output level equal to 1. Now after that here we are going to define our training data, and here we are going to define our negative data. So here we are using a negotiation operator for the negative data. Now we are going to merge the balanced data. So pd dot concatenation, we are going to call our train data, we are going to call our negative data. From the sample we are going to call the length of our training data, random state and access equal to 1. Now we are going to shuffle the order of the training data. So df underscore train n sample length of the training, and again here we are going to calculate the train balanced prevalence. So what I can do, let me run this particular cell. Now as you can see train balance prevalence that we have a 50%, a 0.50, it means a 50% that we have. Now what we are going to do, now we are going to split the validation data into the positive and negative. So let me call here a same way that we can call, this is for our training data. Now we are going to call for the validation data. So let me define here. So again row positive df valid output level equal to 1. So this is for our positive and this is for our negative data that we are going to call here. Okay, now after that here we are going to merge our complete balanced data. So df valid pd dot concatenation a valid positive data, negative data from the sample that we are going to take, and then here we are going to call the random state, because if I show you our let me show you our this particular point again. So as you can see here in a negative that we have the more value and in a positive that we have the less value. Okay, so that's why we are going to take the sample from our negative data. So what I can do, let me copy this particular complete code so that no need to go back again and again. Okay, so let me go down once, and here I'm going to take the new shell. Let me run. Okay, so this is our negative negative and the positive data that we have. Okay, now what we are going to do, so here we are going to take the sample from our negative data from this particular data 36,548. We are going to call the length of the positive data and then random state that we are going to define. Now let me run this particular cell. Now as you can see a valid balance privilege that we have a 15%, where that we have the data in equal to 1398. This is for our validation. Now let's call for our test sample as well. So test data, so now we are going to split the test data into the positive into the negative, positive and negative. So let me define here again. So again here that we are going to call our split the test into the positive and negative. We are going to define the variable called row positive, and from our test data we are going to call the level equal to 1. Equal to 1, it means yes, our customers they are going to subscribe our term deposit, loan term deposit. Okay, now after that we have here df underscore test positive and ds underscore for the negative. Again that we are going to take the sample from our negative data, and here we are going to print the our balance prevalence. So let me run. Now as you can see again that we are getting n equal to 1410, and this is our 50% prevalence that we have. Okay, so now here we have our complete data. Now we are able to balance our complete data, whatever the negative and the positive class data that we have. Now what we are going to do? So now we are going to save our all the data, whatever the train data that we have, a validation test, as well as our original data that we have. So now we are going to save our entire data, so that the later part, as we have already cleaned and the balanced data, so no need to work again and again. So let me save our complete data into the CSV format. So here we are going to save our data. So df underscore train all, we are going to save into the CSV. Again, train data, validation data, and the test data. Let me run this particular cell. So now, yes, successfully run. Let's verify. Yes. So let me rerun this particular home page once. Now, as you can see, now we are able to save our complete data, validation data, train data, test data, as well as our original data. Apart from this one, what we are going to do, whatever the column input data that we have, so what I can do, let me check our complete column input data. So in this way that we can define our main column input data. So somewhere that we have, so if I go up, okay, fine, no issue, later part data I will show you. Let's first of all try to save our data. Okay, let's first of all try to save our data. So what we are going to do, so here we are going to save into the pickle format. So let me save our complete column data. So here we are going to call import pickle, and after that we are going to import our all the input data, whatever the columns input information that we have, we are going to save into the SAV format. We are going to save into the pickle format. Let me run, and here that we are going to call the run statement. Let me run. Yes, now we are able to save. Let's verify once. Now let me rerun our home page. So here we are going to save our all the column input data. Okay, now as you can see, column underscore input dot CSV. So now we are able to save our complete data into the column input. If I show you in this way, so yes, now as you can see, here we have our all the column input data, where we have our categorical data as well as our numerical data. So here we have, first of all, that we call our all the categorical data. So somewhere if I show you, so yes, column number, numerical data, categorical data, and after that we are going to create a variable column input, where we are going to merge our categorical data and the numerical data. Same thing that I have saved into the SAV format, we can say the pickle format. Okay, now let me go down again, and after that what we are going to do, so we have done our complete shuffling of our data into the training, into the testing, as well as into the validation. So now what we are going to do, so we are going to create a function to fill the missing value if during the shuffling and during the explanation and during the like whatever the imbalanced data that we have filled it, right. So now what we are going to do, so we are going to create a function so that whatever the missing value that we have in our data set, that we can fill it out easily. So what I'm going to do, so I'm going to create a complete function to fill out the missing value. So let me define here. So define a function to fill out the missing value, where we are going to call our df, our original data, df mean, okay, and the column to use in whatever the column that we are going to fill our missing value. Okay, now this particular function fill the missing value, check the columns are present or not. So we are going to check one by one all the columns. So we are going to iterate for C in our column to use, and then we are going to use the asset function, and with the help of asset function that we are going to check, okay, so in which column that we have the missing value, and if we have the missing value, in this case try to fill those particular missing value with the mean. So here that we are going to replace with the mean, right. Now let me run this particular cell. So this particular function mainly it will help us to fill the missing value with the mean. Now what I'm going to do, so now I'm going to call our training data. So let me call our training data. So here that we are going to call our save, so df underscore mean. So first that we are going to call our all the train data. So let me, okay, so why that I'm getting the close black symbol here. So okay, fine, no issue. So what we are going to do, so df underscore train underscore all, we are going to call all the input data, whatever the input data that we have, like the categorical and the numerical features, that we are going to call dot mean access equal to 0. It means that we are going to check the row wise. Now we are going to save into the CSV format, so df underscore mean, and then we are going to save. Let me run this particular cell. Okay, so now we are going to apply first that we are going to call all the train data, where we are going to call our all the numerical as well as our categorical features, and then we are going to save. Okay, now what I'm going to do, now I'm going to read this particular data. So let's try to read this particular df underscore mean dot csv file. So here we are going to read. Let me run. Now what we are going to do here, so df underscore mean underscore in, So we are going to read our df underscore mean data, where we have a name called column and the mean value, whatever the mean value that we have for the particular column. So here for the NAN 0, for the campaign 2.5, for the P days that we have the 962, previous 0.17, and the empower rate that we have our 0.7. Okay, now what we are going to do, so now we are going to use this particular function of fill missing value, fill by missing function on our train data as well as on our validation data and our original data. Okay, so we are going to fill the missing value with the mean. So let me define our complete variable to fill the missing value with the mean. So here we are going to create a 3 variable called train df train underscore all for training data as well as for the testing validation data. Here we are going to call the function fill by missing. So all the function that we are going to call. Now we are going to call our data. So df train all the data that we are going to call. Here we are going to call only train data. Here we are going to call only our original validation data. Okay, now here we are going to call the mean. So whatever the mean variable that we have, so this one, and then we are going to call our input. Let me run. Okay, now what we are going to do here, so here we are able to fill our all the missing value. Now after that what we are going to do, so we are going to create a matrix for the x as well as for our y. So here we are going to divide our complete data into the dependent and independent. Okay, so independent and independent features. So let me run here, let me define. So here what we are going to do, so again we are going to create the x and y matrix. We are going to call x train all, and the validation y train all, and we are going to call our train. So here this is our target column that we have, and this is our dependent or independent features that we are going to divide our original data. And then we are going to check our shape of our all the training shape for the testing shape as well as training all shape for our original data. Let me run. Now as you can see, this is our complete training all shape that we have, 28,832. For our training shape that we have the 64,000, and for the validation shape that we have 1,398. Okay, and these are the complete our column that we have. Okay, so now here we are able to split our complete data. We are able to create the matrix for our x and y. Now what we are going to do, so whatever the data that we have, so if I run our x train all data, so yes, this is the x train all data that we have. Now if I show you our x train data, so yes, this is the x train data that we have, and if I show you our x validation data, so yes, this is our x validation data that we have. So all the data as you can see we have in a different format. So now what we are going to do, so now we are going to scale our complete data into the one format. Okay, so we are going to apply the scaling. Okay, so for this one what we are going to do, first of all that we are going to import a standard scaler, so that whatever the different format data that we have, we can do the formatting in the one format. So let me run. Okay, now we are able to import. So we are going to create the object, and then we can define our data. So here first that we are going to create the object, and after that we are going to fit scalar.fit, and we are going to apply over the original data called x underscore train underscore all. Let me run. And now if I show you, so yeah, this is the our complete, we are able to apply the standard scalar on our x train on data. Now what we are going to do, so now we are going to save into the SAV format our scalar data. So let's save so that the later part that we can use. So first that we are going to define a variable called scalar file. Now we are going to dump, so pickle.dump scalar, and then we are going to open the file, and after that we are going to write WB, it means a write mode. So let me run. Okay, now if I refresh this particular home page, so here that we will get scalar.sav file. So we are able to save into the SAV format. Now after that what we are going to do, so we are going to open our pickle file. So whatever this particular SAV file that we have, so scalar equal to pickle.load. So we are going to load this particular file, scalar file, into the RB mode. RB mode, it means that we are going to read our data. So let me run. Okay, now what we are going to do, so now that we are going to apply the transformation on our data. So what we are going to do, so we are going to transform our data matrix, whatever the data matrix that we have created here. So this particular data that we are going to transform. So for this one what we can do, we can use a transform operation over our extend data and our x validation data. So yes, extend underscore tf, x val underscore tf, we are going to call the scalar variable, and then we are going to transform our complete data extend and x validation. Let me run this particular shell. Yes, So now if I show you this particular data now, so yes, this is our complete scaling data that we have. Now if I show you our X validation DF, so yes, this is our complete validation data that we have, a scaling validation data. So now we are able to transform our complete train data as well as our validation data. Okay, now what we can do next, we can start a model selection. Model selection. So model selection, let me add as a markdown. So what we are going to do in this particular section, first of all, that we are going to use a multiple machine learning algorithms. Now after using a multiple machine learning algorithm, that we can check it out the performance over our validation data set, and then we can select a final best model, and then we can save into the pickle file, so that the later part that we can use for the deployment purpose, or that we can use for the web application creation part. Okay, so first that we can use a multiple machine learning algorithm, that we can check it out the performance over our validation data set, and then we can select our final best model. So what I'm going to do here, let's try to import first of all our all the important matrix. So we are going to import our all the important matrix. So define from sklearn.matrix, we are going to import ROC, OSC, accuracy score, precision score, recall score, and the F1 score. After that, we are going to create a function to calculate the specificity. Okay, where we are going to define our actual as well as a prediction, and then a threshold. Okay, so as this is the classification problem that we have, so we can set the threshold, and based upon the probability threshold that we can decide, okay, our customers, they can subscribe our term deposit loan or not. Okay, now here we are going to return a sum of y prediction less than the threshold, and this is the complete condition that we are going to write, and based upon the condition that we are going to return our complete calculate the specificity. So we are going to calculate based upon this particular return statement. Now what we are going to do, so now we are going to write our second function, and in a second function that we are going to create a complete report related to our all the matrix related to our ROC, AOC, accuracy score, precision, recall, and the F1 score. So let me define here complete function. So yes, this is the complete function that we have. We are going to define a function to print the report where we have our actual, y pred, and the threshold. Now here we are going to calculate the AOC, accuracy, recall, precision, specificity, and the F1 score. So these are the complete formula that we have. So we are going to use directly a formula. Okay, now after that, here we are going to print our AOC, ROC, recall, precision, specificity, calculate the prevalence, and the F1 score. Okay, and here we are going to return our complete AOC, like recall, accuracy, precision, and then F1 score. Let me run this particular cell. Okay, now what we are going to do, so now we are going to set the threshold. As you can see here that we are going to pass one argument called threshold, and based upon this particular threshold that we can set, we can get the complete probability related to yes or no, our customers, they can subscribe our term deposit loan or not. So let me set the threshold equal to 0.5, that we are going to set our complete threshold. Based upon this particular threshold that we can classify our complete customers. So let me run this particular cell. Okay, now after that, what we are going to do, so next that we can use a multiple machine learning algorithm. As I mentioned that we are going to use a multiple machine learning algorithm, and based upon the performance of our validation data set, then we can select our final best model. So here we are going to use a multiple machine learning algorithms like KNN, logistic regression, a stochastic gradient descent, a Navier Bayes decision tree, random forest, a gradient boosting. So multiple machine learning algorithms that we are going to use, and based upon the performance over the validation data, then we can select our final model. So let's try to start with the KNN. So here first that we are going to start with the KNN algorithm. Now let me define here. So yes, first of all that we are going to import a KNN classifier where we are going to set the neighbors equal to 100, and then we are going to fit our X train DF and the Y train DF. Let me run this particular shell. So yes, now here we are able to create the complete object. Now what I'm going to do, so now I'm going to add the print, or let me add in the same cell. So what I'm going to do here, that I'm going to add the print statement. So print the KNN training. Here we are going to call the KNN train accuracy, train KNN train accuracy, train AOC, train recall, precision, specificity, F1 score, and then we are going to call the print report, this particular function that we are going to call, and after that we are going to pass all the argument for the training as well as for the testing. Now let me run this particular cell again. Okay, so here I got the error called y prediction is not defined. Where is the y prediction that we have? So report y pred. So y pred that we have here. Okay, so we need to call our y pred. So what I'm going to do, let me copy this particular cell. Okay, let me run. Let's create the object first of all. Now what we are going to do, so now we are going to define y pred and y validation pred. So what I'm going to do, so here again that I'm going to create a two variable. So let me create a variable first of all. So validation, and let's create for the training purpose as well. So yes, let me run. Now here we are able to create the complete y train prediction and the y validation prediction. We are going to call the predict probability function. If I show you, so we have created a predict probability function. So we are going to define a predict probability function from the knn that we are going to import. Okay, so from the knn that we are going to import predict probability function, where we are going to pass our extend data, and we are going to take our all the column apart from the target column. Okay, now let's try to print our complete AOC, ROC, F1 score, each and everything. So here that we are going to define print statement first, and then we are going to print. So let me run. Now as you can see, this is the complete accuracy that we are getting. So knn, so first that we are getting the print statement, training, AOC that we are getting a 79%, and for the validation that we are getting the 77%. Now if I talk about the accuracy, so 73, here we are getting the accuracy 74, recall 60, precision 83, precision 81, again prevalence that we are getting 50, fine, and the F1 score 69. Okay, so this is our complete accuracy that we are getting, accuracy and the complete matrix that we are getting over our training data set. So for the training set, like we are able to get the AOC called, we can say the 79%. Okay, now we have, if I talk about the our recall, so recall that we have a 60%. Okay, so now again if we are going to set the threshold called 0.5, so again this is the good that we can show. So accuracy AOC by 79 or the recall by that we are getting 60. So in this case that we can show, okay, so this is the, like, yes, this is the good model that we have. Our customers, our like potential customers using the threshold that we will get the good results. Okay, now what we are going to do, so now we are going to apply the next model called logistic regression. So let me define here again next model, logistic regression. Let me create the complete object. So first that we are going to import the logistic regression, we are going to create the object, and after that we are going to fit over our x train and y train. Let me run this particular shell. So now we are able to create the complete object, same way that we can call the probability class x for the x train and the validation. Then we can print our complete accuracy, AOC, recall, precision, F1 score, each and everything for our all the algorithm. So let me run. Here again we are going to call our y train, y validation prediction. We are going to print a statement, and then we are going to print our for our x train data as well as for our x test data. So let me run this particular cell. So now if I talk about the AOC, so here that we have 79 and the recall that we have a 63. So again this is like the, we can say not a good one, but we can say the yes, we have a fair model that we have here. Okay, now next that we are going to use a SGD model. So let me use a SGD. So SGD, now let's try to import first of all our all the important library. Now here we are going to call a loss equal to log loss, now alpha 0.1 and the random state 42. Now we are going to fit. So let me run. This is the complete object that we have created. Now let's define the y pred for our x train and for our validation. So yes, this is complete y pred that we have. Now here that we are going to print is, we are going to call the print statement for the training and for the validation. Let me run. Yes, so these are the complete training and the validation accuracy that we are getting, accuracy, AOC, recall, precision, F1 score and all for our training as well as for our validation. Now what we are going to do, so now we are going to use the Navis Bayes algorithm. So first let's try to import. So here that we are going to call the Navis Bayes. So let me import. So first that we are going to import the Gaussian NV. We are going to create the object, and then we are going to fit our over our x train and y train data. Now this is the object that we have. So now what I'm going to do, same thing that we can call the, we can create the two variable for x train probability and for the y train probability. Let me define here. Okay, so again that we are going to calculate the training accuracy and the validation accuracy. Let me run. Yes, so AOC 77 and the recall that we are getting a 49. So yes, AOC is 78. So yeah, again that we can see the fair model that we have. Now let's try to use a decision tree. So DT, decision tree model that we are going to use. Let me import first of all our library. Now we are going to create the object for the decision tree classifier. After that we are going to fit our model over the X-train and the Y-train data. So yes, this is our complete object that we have created. Now let's try to create a variable for Y-train prediction and Y-train paid and Y validation paid. Okay, so yes, let me run. Now as you can see, this is the complete decision tree training AOC ROC value that we have, and this is for our validation that we have. Okay, now what I'm going to do, so same way that we are going to create, and based upon the accuracy then we can select the final model. So what I'm going to do, so now let's try to define for the random forest. Okay, so here that we are going to define for the random forest RF. We are going to import a random forest algorithm. We are going to create the object and then we are going to fit our complete model. So let me run this particular cell. Now we are going to create a variable for Y train paid and Y validation paid. Let's create object, a variable. Let me run. Now AOC 83 and the recall that we have a 63. So AOC 79 and the recall that we have a 64. So again that we can see the fair, not a good, a fair that we can see. Okay, now let me run our this one, what I can say, the gradient boosting. So let me define here a gradient boosting. So gradient boosting GV. Let me create the object first of all. So first that we are going to create the object, and after that we can define a variable called Y paid, Y train paid and Y validation paid. So let me define here. Okay, so these are the complete model that we are getting for like accuracy, ROC, recall, precision, FRS code. Now what we are going to do, now we are going to analyze our complete model. So analyze our model. So let me create as a markdown. Let me run this particular shell. Okay, so now we are going to analyze our complete model. So first of all we are going to create a data frame for our all the models. So classifier, KNN, logistic regression, okay, logistic regression, SGD, Navish base, a decision tree, random forest and the GV. Okay, now we are going to call train and validation, accuracy, precision, recall, specificity and the FN score. Let me run. So here we are going to create our complete data frame related to our all the model. Okay, now we are going to import the C1, so matplotlib and C1. So let me run this particular shell, and after that what I'm going to do, so I'm going to do the plotting. So let me plot here. So yes, this is the plotting that we have. So as you can see, this is the complete graph that we have. So we have first that we have picked the AUC like area under the ROC curve as a performance indicator, and based upon that we can select our model. So here as you can see, this is for our gradient boosting and this is for our AOC that we have. This is the model that we have in a X and Y that we have the model. We have selected the AUC area under the curve. So area under the curve that we have selected, so that based upon this one that we can select based upon the AOC performance that we can select our final model. Okay, now as you can see, for the gradient boosting, this is the accuracy that we are getting for the training and this is the validation that we have. For the random forest that we have this one, so random forest that we are getting a good little bit. Now decision tree, so we have some of like little bit difference that we have. Now Gaussian, below training accuracy, training AOC that we have the less as compared to the validation. Now again for the SGD training AOC that we have the less as compared to validation. Now for the linear logistic regression we have the similar, and for the KNN that we have the highest training accuracy as compared to the validation. Okay, now what I'm going to do, so now that we are going to plot the learning curve, so let's try to plot the learning curve, and based upon the learning curve then we can select our final model. So as you can see, if I talk about the gradient boosting, so in a gradient boosting that we are getting our we can say almost here 60-80, so we can say 70% of the model that we are getting. Okay, for the gradient boosting, right? Gradient descent, SGD, yeah, gradient descent. Okay, so for the gradient boosting that we are getting approx, we can say the 85 or the 90% of the AOC. So we can say this is the best AOC that we are getting 80%. Even over the validation that we are getting a good accuracy, right? So even that we can select what we can say here. So yes, let's select the gradient boosting. Okay, now what I'm going to do, so now we are going to plot the learning curve. So let me plot the learning curve. Let me select the model here, a markdown. Let me run. Okay, Now let's try to import first of all our library for the learning curve. So we are going to import from the model selection, we are going to import a learning curve as well as a shuffle split. Let me run. Okay, now we are going to create a function to plot the learning curve. So here we are going to create a complete function. So let me create the function here. So this is the function that we have, and in this particular function that we are going to pass some of the parameter called in estimator, a title, as well as x and y. So these are the complete argument that we are going to call. Now let's try to define a complete code under this particular function so that we can plot the graph. So yes, let's define. So yes, this is the complete. Okay, so here that we are getting, okay, so we need to add, yes. So now what we are going to do, so plt figure a title that we are going to define, and after that we are going to call for the training examples AOC. Okay, now here we have our complete training score and the cross validation score. Let me run this particular cell first. Okay, so yes, this is the complete, just wait some time. So yes, now we are able to create the complete function. Now what we are going to do, so now we are going to call our random forest algorithm. So let's define the random forest. Here we are going to import the random forest learning curve that we are going to define a title called random forest. Cross validation that we are going to define 5. So cross validation with 5 iteration to get the smoother mean test on the train. Okay, now score curve each time with the 20% of the data randomly selected as a validation set. So let me run. Now let's wait some time to get our complete graph. Okay, so just wait some time. After that we can check it out, our graph. Okay, but as for this particular data that we are getting a good that we can say in a gradient boosting 80% of the accuracy that we are getting. Now as you can see, we are able to get the complete graph. So yes, this is the complete graph that we have over our training score as well as a cross validation score. So now as you can see, as we are using the random forest, a random forest classifier, so we can see in our model has the high variance because of the training and because of the training as well as a cross validation score, right? As for the data that we can say, okay, so in our data, in our model that we have the high variance whatever the random forest algorithm that we have selected. So now we got to know, okay, so in our model that we have the high variance. Now how that we can handle the high variance data? So again, high variance and the high biases. So again, we have the like many model. High variance, it means the overfitting. Okay, so high variance, it means the overfitting. It means now that we need to handle this particular high variance and the high bias. So we have many techniques to handle the high variance data as well, high variance model as well as a high bias model. So first we can handle the high variance with the, we can add the more sample data, we can do the regularization, we can reduce the number of the features, we can decrease the complexity, we can add the like the better features, as well as we can change our model. So these are the way that we have to handle our high variance model. So let me define as a comment here. So these are the some of the way that we have, and with the help of this particular way that we can handle a high variance as well as high biases data. Okay, now what we are going to do, so now that we are going to focus on the feature importance part. So let me add a feature importance, let me add as a markdown. So now we are going to work on the feature importance. So to work on the feature importance, so in this section mainly that like we can use the feature importance, we can focus on the features importance over our different features, whatever the features that we have, and depending on the importance score of some of the features that we can focus on our high importance features, and then we can perform our AOC again, AOC score again, and based upon that we can select, we can improve our model. So first what we are going to do, so in the initial model that we have used our all the features. Now what we are going to do, now we are going to do the feature importance, and based upon the feature importance, whatever the important features that we will get, so we can use the all important features to improve our AOC score. Okay, so let's try to call first of all for the linear logistic regression for the feature importance. So we are going to import the library, we are going to create the object, and then we are going to fit our model. Now let me run. Okay, so we are able to create the complete object. Now we are going to create a variable related to the feature importance. So yes, feature importance, we are going to call the data frame a linear coefficient, and the data that we are going to call our all the input data, whatever the categorical and numerical data that we have. Now columns wise importance, and then we are going to sort based upon the importance in a descending order. So let me run this particular cell. Okay, now I am going to call this particular feature importance variable. So let me call this particular feature importance variable. Now as you can see here, as you can see, we have the cons price IDX column. So this is the more important feature that we have. After that, Euribor, now month August, NR employed, month year. So again, like we have the many importance features. What we are going to do now, we are going to do the plotting. So let's try to plot for our feature importance data. So yes, we are going to create a variable num, and num dot mean total 15 length that we are going to check. Now y log that we are going to call the arrange function. Now get the feature importance for top num and sort in the reverse order. So we are going to create a two variable, value to is plot and the features label, and this is the complete graph that we are going to plot. Let me run this particular cell. Now as you can see, this is the output that we are getting. This is the complete output that we have, a feature importance. So first that we have cons price IDX. Let's try to match cons price IDX a 94%. Now after that, Euribor and the month August. So yes, Euribor 3M and the month August. So these are the important feature that we have, and the so on that we are getting a less important. Again, that we have some of the negative importance features as well. So what we can do in this case, so we can like drop the less important features and we can use the highly important features only. Okay, so now what I'm going to do, so let me define first of all our next here. So yes, what we are going to do here, so we are going to call the two variables, values to plot and the features level. Here we are going to call the feature importance. So this particular feature importance variable that we are going to call here, and from here that we are going to remove the negative one. So first that we are going to plot in a like first that we are going to call the negative number a value dot reveal, and then we are going to call the features importance. Okay, now again we are going to do the plotting. So features importance score and negative features importance score for the logistic regression. Now if I show you here, so here that we have the positive feature importance, here we are going to call the negative feature importance. So let me run this particular cell. So again, in a negative feature importance that we have some of the column called EMP, var rate, a P days, a month May, a contact, telephone. So these are some of the negative importance features that we have in our data. Okay, so in case of the high variance, what we can do, so we can reduce the number of the variable if we have a high variance in our logistic regression model, so that we can minimize overfitting. So after analyzing this particular things like that, we can say, okay, so whatever the top in positive and the negative features that we have, or we can say the top in important random forest features that we have, we can just adjust the in number of the performance, so that we can drop our whatever the like high variance data that we have, high variance model that we have. Okay, so whenever we have the high variance, what we can do, we can reduce the number of the variable to minimize our overfitting from our data. Okay, now what we are going to do, so now that we are going to call for the random forest. So let me create the object for the random forest, again that we can check it out, our important features. So random forest rf, let me create the object. So we are going to create the object, we are going to fit the model, again that we are going to call the feature importance. So let me call the feature importance. So these are some of the feature importance column that we have, a total 5, because that we call here the head. So in this case that we get the total 5. Now let me plot the graph. So yes, this is the graph plot that we are going to do, same thing. Now let me run. Now as you can see, these are the some of the feature importance score that we have for our random forest, in our employed, Euribor, EMP var rate, conf, P outcome success. So these are the some of the important that we can say importance score that we have, a feature importance score that we have for our random forest. Okay, now what we are going to do, so now let's try to apply some other algorithm as well, like the random forest, like the gradient boosting. Okay, and apart from this one, that we can apply the decision tree. So many algorithm that we have used. Okay, so what we can do, so like same way that you can use the multiple algorithm, and based upon the multiple algorithms, then you can check it out the complete feature importance, and based upon the feature importance, then what you can do, then you can do the complete plotting. Okay, so what we are going to do, so let's try to do the plotting for our some other model as well. So for our gradient boosting or decision tree. Okay, so first let's try to do the plotting of feature importance for our gradient boosting. So gradient boosting, let's create the object. So we are going to create the object in a first place. Now we are going to check the random like the feature importance. So again feature importance, so these are the some of the feature importance that we have for our gradient boosting algorithm. Now let's try to plot the complete graph. So yes, we are going to plot the complete graph. So let's wait. So yes, this is the complete graph that we have. Now we realize that our features has the more positive impact on our predictive outcome. Based upon this one, that we are able to understand, okay, so whatever the features that we have, now we have the more positive impact over our positive outcome. So which one? Our that we can say the Euribor 3M. So this particular features, we can say the 3-month rate daily indicator, as well as our age is a very crucial, as there the importance is higher than our other numerical features. So these are the two numerical features that we have. Right now, this particular two features, it's play a very important role whenever we are going to use a gradient boosting classifier machine learning algorithm. Again, here these are the some of the important features that we have, like the inner employed, cons, Euribor 3, age, campaign, and the so on. Okay, now what we are going to do? So now we are going to use a decision tree algorithm. So decision tree algorithm, let's try to write first of all a comment, decision tree. Now let's create an object. After that, we are going to create a variable for the feature importance. Let's create a variable. Now as you can see, again the Euribor and the age 3, this is the important features that we have, same as our gradient in our gradient boosting that we have. Right now let me do the plotting. So here we are going to do the plotting. So yes, this is the complete plotting that we have. So again, these are the top 5 feature importance features that we have in our data set. Now what we are going to do? So now that we are going to use a hyperparameter tuning so that we can improve our model performance. So let me add the hyperparameter tuning here. So yes, here I am going to add the comment called hyperparameter tuning. Let me add as a markdown. Yes. Now what we are going to do? So let's try to define a complete code for the hyperparameter tuning. So first of all, train the model for the each max depth in a list, and then store the AOC for the training and the validation set. So we are going to define the max depth here. Now we are going to call the training accuracy and the validation accuracy, and after that a maximum depth that we are going to iterate one by one for the random forest algorithm. So here we are going to use a random forest. So n estimator wise, if I talk about the n estimator, so n estimator, this is the hyperparameter that we have in our random forest. So it's depending upon our number of the estimator, whatever the number of the estimator that we are going to put it down over our random forest classifier object. Okay, now what I'm going to do? So we have our max depth and we have the random state. After that we are going to fit our model, and here we are going to call the train prediction and the validation prediction. After that we are going to calculate the complete accuracy for our train, accuracy for our test. So let me run this particular cell. Yes, now we are going to save here. So let me do the plotting. So matplotlib, we are going to do the plotting for our train AOC and for the validation AOC. Now let me run. So yes, this is our complete graph that we have. So as you can see here that we are using a random forest classifier that we are using. Now based upon this particular random forest classifier, this is the complete graph that we are getting for our max depth. So this particular graph that we have for our training, and this particular graph that we have for our testing. Okay, now what we are going to do? So now let's try to use a randomized search CV, and with the help of randomized search CV that we can optimize our few of the like baseline model, whatever the model that we are using. So few of the model that we can optimize with the help of randomized search CV. So yeah, let's try to write a code for the randomized, but before this one, let's try to get the complete parameter for our random forest, for this particular random forest. So let me define here. So yes, now let me call. So yes, these are the some of the random forest like parameter that we have, bootstrap, CCP alpha, class bit, creation, max depth, n feature, and the so on. These are the complete parameter that we have. Now let's try to create a complete randomized search CV. So we are going to use a randomized search CV so that we can optimize our few of the baseline models. So let's try to define here. So we are going to import first of all randomized search CV from the sklearn.model selection, a range that we are going to define for the n estimator, the number of the trees, a maximum number of the features that we are going to use so that we can split. Now after that we are going to define the max depth, number of the split, and then creation, and after that here we are going to create a random grid, a randomized search CV, and these are the some argument, we can say a parameter that we are going to define, and then we are going to print our all the random grid. Let me run. So yes, these are the complete argument that we are going to define. Now what I'm going to do, so now I'm going to import our AOC ROC score. So let me import. So from the matrix that we are going to import MAC score and the ROC AOC score, and here we are going to call create the object for the make score. Let me run. Okay, so now we are able to create the complete make score object. Now let's try to create a baseline for our random forest. So let me create the baseline for our random forest model. So yes, create the baseline for our random forest classifier. Now we are going to create the randomized search for the cross validation. So randomized search CV estimator that we are going to pass random forest parameter by random. So this particular random grid iteration 20 times CV cross validation that we are going to define 2 score that we are going to define our what AOC ROC score. After that verbose that we have and the random state that we have. Let me run. Now we are able to create the random rf underscore random for our randomized search CV. Now what we are going to do, so now that we are going to fit the model, and the same time that I want to check the time. So for this one that we are going to import the time. So fit the random search model, and this will take a few minutes. So again that we are going to call the timing here, and then we are going to fit over our train data, and then this is the timing that we are going to calculate mainly, and we are going to fit our model. So let me run. So again fitting twofold for each of 20 candidates. So here iteration by we are going to call a 20 iteration, and total fitting that we have a 40, because 20 into 2 a 2 iteration that we have. So CV 2 iteration, it means a 40 that we have. Okay, so it will take a few seconds to fit our complete randomized search CV. Okay, so this particular randomized search CV that we are going to fit over our X train and the Y train data. So here we have the iteration called 20 and the CV that we have 2. So cross validation equal to 2. It means a total 20 times it will get fit. Okay, so it will take a few seconds, and after that we will get the complete timing here. So whatever the timing it will take, like the 50 second or the 60 second, 1 minute or 2 minutes. So with the complete output that we will get, as we are calling here a print statement. After that what we can do, so we can call our best model from our randomized search CV. So whatever the like argument that we are going to define, whatever the parameter that we are going to define in our randomized search CV. So from here that we can call our best parameter, and then we can use a random forest classifier again. Okay, so yes, let's wait a few seconds till the completion of this particular things, and then we can continue. Now as you can see, it took the approx 88 seconds. Okay, now what we are going to do, so now that we are going to call the best parameter from this particular randomized search CV. So let's try to get the complete base parameter. So yes, these are the some of the base parameter that we have. The n estimator 100, mean sample split 4, max features squared, and the max depth 8, and the creation that we have the Guinea. Now what we are going to do, so now we are going to use a random forest classifier. Okay, and then we will get our best model. Like again that we can use a multiple model. Okay, so let's first of all try to start with the random forest. So again here we are going to import, we are going to create the random forest classifier object. We are going to fit our X train and the Y train data. Here we are going to call the predict class for our Y train and the validation. We are going to set the threshold. We are going to print the baseline random forest. Okay, for our AOC score for our Y train and Y pred, and the Y valid for the Y validation and Y validation pred. Okay, now again that we are going to call the base estimator random forest. Okay, so optimized random forest, and this is the baseline model that we have. So again two things, baseline as well as our optimized one. Let me run this particular cell. Again as you can see, the baseline random forest training that we are getting 81, and training AOC 81, and for the optimized one that we are getting 84. So now we are able to increase a 3%. Okay, for the AOC. Now if I talk about the validation 79, and the validation that we have the same, but for the training that we are able to increase 3%. Now what we are going to do, so now we are going to use a next algorithm called SGD. So yes, SGD, let me run this particular cell. So we are going to fit the model, and then we are going to create the object. Again we are going to call the parameter. So yes, penalty, max iteration, alpha, random grid search. For the SGD we are going to create the random grid search, a complete object. Then we are going to calculate the time again here. Again it will take a few seconds. So now as you can see, 1 point some second. Okay, now we are going to find out the base parameter based upon this particular parameter. So again SGD random and the base parameter. Let me run this particular cell. So these are the base parameter that we have. Now based upon this particular parameter that we are going to do the training with the help of our SGD classifier model. So yes, this is the complete code that we have. So first that we are going to call our Y train pred and the Y validation pred. We are going to set the threshold. Here we are going to call the baseline model, and this is for the optimized model. Let me run this particular cell. So yes, we have the baseline HGD called training accuracy 79, validation 80, optimized one training 79. So here that we are getting the same output that we are getting, whatever the baseline model accuracy that we have, and whatever the same for the baseline as well as same for the HGD. Now let's try to calculate for the gradient boosting. So yes, we are going to create the complete object for our gradient boosting. Now let's try to define our complete parameters. So n estimator, max depth, learning rate, a grid. Here we are going to call all the grid. Again that we are going to create a object for the random search CV. Let me call. Again it will take a few seconds to execute, and after that we can call again the base parameter, and based upon the base parameter then we can do the training with the help of our gradient boosting algorithm. So let's wait a few more seconds till the execution, and after that we can find out our base parameter based upon whatever the parameter that we are going to pass, and then we can train our model. Okay, so let's wait few more seconds. It will take a few more seconds to do the complete execution. Okay, now as you can see it took a 35 seconds. Now let's try to find out the base parameters. So here we are going to find out the base parameter. So yes, these are the base parameter that we have for the n estimator 150, max depth 2, learning rate 0.1. Now let's try to train our complete model. So yes, we are going to train our complete model. Let me run this particular cell. Now for the baseline gradient boosting classifier that we are getting a 90%. Now if I talk about the optimized one, so we are getting 81, for the validation 71, and for the validation that we are getting 79. So in a validation that we are able to increase a 2%. Right. Now what we are going to do? So we are going to create the object for our all the three algorithms. So yes, we are going to create the object for the classifier, a data set, and the AOC that we are going to define. Let me run this particular cell. Now let's try to run our df results variable. So yes, this is the df results variable that we have, a classifier model. This is the data set that we have for the baseline and optimize. So AOC, baseline and optimize same, random forest almost same, and for the gradient boosting almost same that we have. Okay, later part that we can plot the complete graph. So let's plot the graph parallelly. Okay, so now we can compare the performance of our optimized model to the our base model. Okay, so let me plot the graph. So here we are going to import our all the library. We are going to call the bar plot, classifier, AOC, and the data set, and label that we are going to set, and after that we are going to plot the graph. Now let's plot the graph. So here as you can see that we are getting HGD, we are getting our random forest and the gradient boosting. Now here as a data scientist, as a senior data scientist, or we can say the data scientist, that we can select our gradient boosting is a optimized version, or we can say we can select our gradient boosting model as a base model, because whatever the optimized version higher accuracy that we are getting. So if I show you, so here as you can see the optimized AOC score that we are getting a 79, and this is the higher matrix that we have based upon our baseline. So this is for the baseline 77, and this is for the our optimized a 79. Okay, so in this case that we can select our gradient boosting. Again you can compare with the HGD. So here this is the result that we have for the HGD, and this is for the random forest. So similar result that we are getting for our HGD in our baseline as well as in optimized, as well as for the random forest we are getting the similar result in a baseline and in a optimized. But in a gradient boosting, in a baseline that we are getting 77, and in a optimized that we are getting a 79. So what we can do here, that we can select our final model called a gradient boosting classifier. Now what we are going to do? So now let's try to save our gradient boosting model in a pickle format, so that the later part that we can use this particular model to create a complete web application. So let's use. Okay, so here we are going to dump, and we are going to save into the pickle format. Let me save. Let's verify once. So yes, we are able to save our base classifier.pickle file here. Okay, now what we are going to do? Now we are going to do the model evaluation. So yes, let me define here a model evaluation. Let me add as a markdown here. Okay, so let's first of all try to import our all the important libraries. So these are the library that we need. Okay, pandas, matplotlib, numpy, and the pickle. Now we are going to load our model. So whatever the model that we have, so let's try to load our model. So here we are going to load our base model, base classifier model. We are going to load our all the input data, where we have our categorical and numerical data. We are going to read our means.csv, and we are going to load our scalar.sav file. Okay, our scaling data. Let me run this particular cell. Okay, so now we are able to load our model a column, mean value as well as scalar. Okay, now what we are going to do, now let's try to read our complete train data. So read our train data, validation data, test data. So all the data that we are going to read here. So let me read. We are going to load the data for our train.csv, validation and the test. So let me run. Now we are able to load our complete data. Now after that, what we can do, as we are going to do the data validation. So first of all, that we can fill our missing value, we can create the features, dependent and independent features, we can transform our data, and then we can predict the probabilities. So let's try to fill the missing value. So we are going to fill the missing value for our train data, validation and test data. We are going to create the features for X train, validation, X test. We are going to again for the, this is for the X train, X test and X validation. Again Y train, Y validation, Y test. We are going to transform our complete data. Let me run this particular cell. So now we are able to transform our complete data. Now we are going to do the prediction, a probability prediction. Okay, so yes, we are going to call the base model dot predict probability function, and then we are going to apply over the X train, X validation and X test on this particular data. So let me run. After that, what we can do, now that we can check the model performance, now that we can evaluate the performance, not a model performance, we can evaluate the performance. So first of all, that we need to set the threshold. So let's set the threshold called 0.5 or 50% of the threshold, and based upon this one, that we are going to do the complete like evaluation for our performance. So yes, print the training, print the validation and print the test. Okay, so we are going to print the all the training accuracy, validation accuracy, test accuracy for everything, AOC, accuracy, recall, precision, F1 score and all. Let me run. So yes, this is our complete output that we are getting. So here in this particular output, as you can see, we have a training, we have a validation and we have the test. Okay, so yes, we have the AOC called 81 for our training, for our validation 79 and for our testing that we have 79. So same, like we have checked the mainly AOC, we are going to focus on the AOC, and based upon the AOC that we are going to select our final model. Now what we are going to do, so this is the complete accuracy, AOC, recall, precision, F1 score, complete output that we are getting. Now what we are going to do, now we are going to plot the graph for ROC curve. So let's try to plot a ROC curve. So for the ROC curve, again that we are going to plot here, let me add a comment, ROC curve, ROC curve. So let me add as a markdown. So here not a O, is a U. Let me run. ROC. Let me define a complete code. So yes, we are going to import our scalar.matrix ROC curve, FRT train, TPR train, threshold that we are going to set for the accuracy train, for the validation, for the like validation FPR, and the accuracy again for the testing for FPR and the accuracy. So we are going to call these things, and after that we are going to plot FPR as well as our accuracy. So let me run. Now as you can see, this is the complete graph that we are getting, and here is the highest accuracy that we have, the training accuracy called 81%. Okay, now our data, as for our data, as you can see, this is the complete result that we are getting for our training, for our validation as well as for our test data set. Okay, now here as you can see that we are getting on our, based upon our threshold, like whatever the threshold that we have set 0.5. okay, and based upon our threshold that we are getting over the test AOC that we are getting a 79. So yes, test accuracy that AOC that we are getting 79 over the gradient mostly. And the performance, if I talk about the model performance, so the model performance over the validation that we have a 79, over the test that we have ours, like over the validation again that we have the 79, and over the test again that we have our 79. Okay, so this is our complete ROC graph that we have over the false positive as well as a true positive, TPR as well as FPR. Okay, so yes, we are getting our best model, even this is the complete graph that we are getting for the AOC, ROC, and we are able to test over our test data set, our complete model that we are able to test our the test data set. And yes, this is the correct, we can say the good accuracy that we are getting, a good AOC output that we are getting over our test data set. Okay, so yes guys, this is all about our complete bank marketing project. Based upon this one that we are able to find out, okay, so whatever our customers that we have. Okay, so based upon this particular complete analysis, that I have one of the complete comments. So let me write down the complete comment here. So yes, this is the complete comment that we have. Now as you can see, Throughout this particular project, we created a machine learning model that is able to predict how likely clients will subscribe to a bank term deposit. This model was a gradient boosting classifier with optimized hyperparameters, and the model performance that we have a 79.5% of the accuracy. A precision of the 82% divided by the prevalence of the 0.5 give us the 1.6, which means the machine learning model help us 1.6 times better than randomly guessing. Okay, now the model was able to catch 62% of the customer that will subscribe to our term deposit. So again, this is the high accuracy that we have, because as I mentioned, out of 100, whatever the leads that we generate with the help of marketing campaign, out of 100, like if we are able to convert like 5 or 10, like not a 5 or 10, 2 or 3. So it's a great success that we have in the field of marketing. But here that we are able to achieve a 60% of the model performance. Okay, so we are able to catch the 60% of the customer that will subscribe our term deposit loan. Now we can focus on targeting customer with the high cons price IDX, a customer price index, and 3-month indicator for paying off the loan as the high importance features for the model and the business. So as we all know, this is the two high, we can say the high importance features that we have in our data set. So mainly that we can focus on this part, these types of the customers. Therefore, we save the time and the money knowing the characteristics of the client we should market to, and will lead the increased growth and the revenue. Okay, so now we are able to find out our complete customers. We are able to catch the 62% of the customers that will subscribe our term deposit loan. Okay, so yes guys, this is all about our complete machine learning project that we are able to do a lots of things. That we started with the problem statement understanding, that we perform little bit about the ADA, that we understand our data, we can perform a complete feature engineering, we can build the model, then we can validate the model, we can apply multiple machine learning algorithm, we can apply the hyperparameter tuning, then we can find the best model, and after that we can do the testing. Okay, so yes, this is all about our complete machine learning project. Let me know in the comment section guys if you have any doubts related to this particular projects. And yes guys, I have only one request, please share this particular project and all our 30 days machine learning project to your social media platform. Share with your friends or some other other social media platform, LinkedIn, okay, Facebook, so that I will get a reach, and based upon the reach, definitely I will come up with some more interesting deep learning, computer vision and NLP projects. Okay, so yes, this is all about in this particular project. See you in our upcoming project guys. Thank you.